Hey guys, it's Mr. Robinson. I wanted to just take a second to have a video up here to kind of rehash what we were talking about yesterday, and then give you guys some context and some examples of how we use this when we're using slope-intercept form. So yesterday, basically what we were working towards is there's three types of solutions we can get to. Okay, if there was one solution to the system, when we graphed it, you would see there was an intersection. In this intersection, the coordinates of it was our solution. So there'd only be one solution in that case. So those lines that go off into infinity, okay, they will never cross again. This is the only point that these two lines on the same graph share the same space. That's why there's just one solution. Okay, but we also looked at a scenario yesterday where we had two lines that were special kinds of lines. They have those little carrots on them, and we call those parallel lines. Okay, and if there was parallel lines, they're never going to cross. As they go off into space, they'll never come around, they'll never cross. They're always just going to be flying in the exact same direction, just in different parts of the graph. So they're never going to cross. So that would be an example when we have no solutions. Okay, and the key to that one was that they were parallel lines. Parallel lines. That's the big key when there's no solution. Okay, and then the last example we looked at right at the end of class, it's not as common, it's pretty easy to catch, but that is when we have one line here like this, then we have another line on top of that exact same line. Okay, so we have two lines on top of one another, which means they share all their coordinates together, which means there are infinite solutions. Okay, and the reason there are is because they're the same line. Okay, so those are the three things that we're looking at identifying today as we go through our worksheet in class. Okay, we're looking at, can we graph these two lines on the graph together? We're going to look and see, do they cross? If they do cross, we're going to identify there's one solution. If they don't cross, we're going to say there's no solution. And if they're the same line, we're going to say infinite solutions. So let's look at, real quick, I'm going to go through 8 examples pretty quick because we've done lots of graphing already, to kind of show you guys what we're looking at here. Okay, so for example 1, we're looking at a graph that looks like this. We'll make some points here. Okay, and we have a system because there's two lines on this graph. And these lines are y equals 2x minus 3 and y equals negative 3x plus 2. Okay, and if that's the case, what I'm looking at is, first I got to graph my first line. I know minus 3, that's my y-intercept, so I'm going to go down 3. 1, 2, 3. Okay, the 2 is my slope, but I'm going to rewrite that as 2 over 1, because now that tells me to go 1 to the right and 2 up. So I'm going to go 1 to the right and 2 up, and I'm going to graph my line. Okay, notice how my graph's not perfect. Okay, it doesn't have to be perfect. The goal of this is figuring out how many solutions we're dealing with on this worksheet. So for my next one, a little different. My y-intercept is plus 2, so I'm going to go from my origin 2 up. That's where it crosses my y-axis. And this minus 3x, I'm going to rewrite down here as negative 3 over 1, which tells me to go 1 to the right and 3 down. So I'm going to go 1 to the right and 3 down, make my line. And as I can see, these lines cross, so then on my paper I'm going to write one solution. Okay, that's how that one's going to look. Let's look at a different example though, just for funsies, because I know you guys like to do this stuff. Okay, here we go. Get rid of my one solution. We have a graph here, looks like that. Let's look at y equals negative 5 over 3x plus 1 and y equals negative 1 over 3x minus 3. I'm going to kind of go through these a little quicker because we've done lots of graphing. We have two lines. We're trying to figure out, do they cross or do they not? Okay, so in this case, I'm going to start at my y-intercept, which would be minus 3, so right here. And I'm going to move 3 to the right and 1 down. So from here I'm going to go 1, 2, 3 to the right and 1 down. So there is my ballpark where my line is. And then on this one, it's gonna start at +1 is where my line's gonna cross my y-intercept, but it's gonna go 3 to the right and 5 down. So I'm gonna go 1, 2, 3 to the right, and then 5 down. 1, 2, 3, 4, 5. I'm gonna be right about here. Okay, and again, I can see that they're gonna cross right there, so there is one solution. Okay, so that's two examples I've just done that have one solution, and that's probably the most common of them. They usually just have one solution. However, let's take a look at one example that is not that way, so you guys can kind of get an idea of what that looks like. Let's look at if it was. We had y equals 3x plus 1 and y equals 3x plus 5. So we have 1's my first line, going 1 to the right and 3 up. So my line's gonna look something like that. On my next line, I'm gonna go 5 up. So 1, 2, 3, 4, 5 is where my line starts, my y-intercept right here. Okay, and then I'm gonna go 1 to the right and 3 up. So my lines are going to look like this. Now when I look at that, okay, even with my okay drawn graph, I can tell it's trying to show me that these lines are parallel. And if the lines are parallel, that would be a situation where we have no solution. Okay, it's the second most common of them. So today, after you get done with your warm-up stuff, you're gonna jump into this and you're gonna do your warm-up, then you're gonna go get the worksheet from the sub, and we're gonna go from there. So good luck, do your best work, and we will go over it more tomorrow. Thank you.